computer. All right, so let me switch with my awesome use some conversions. So, due today, syllabus quiz. There should be no issues with that. Everyone has had a long time to get that done. On Sunday, make sure that you have your conversions discussions completed. So you need to post or reply twice, or post a video, a question you have, answer someone else's question, post some extra problem sets maybe you found online, anything like that will count as a post. So a combo of any of those things, just 2 of them. A lot of people have been missing the discussions, so make sure everyone's getting them in, especially virtual people. I sent out a reminder email because there was like half the students didn't do it at all. So make sure you're doing the discussions as well. The first homework is going to be due on Sunday as well. So it is Labor Day weekend, so you might want to just do it now because the first homework quiz is on scientific notation, significant figures, and the scientific method. So you don't need to know any of this conversion stuff to do the first homework. So it's the part 1, chapter 1 homework quiz, and that's already up. Coming up next Wednesday, a week from today, you're going to have another homework assignment due, and that will be on conversions and density. Okay, so this first one, you've learned everything you need to know for it, so you can do that at any time. All right. So I'm going to start by continuing conversions. So on Monday, there was a video posted doing some conversions. So we're going to do a few more examples, sort of a review, and then we'll look at experimental error and density if we have time. If we don't get through all of those, I'll post another video on Friday doing some example problems to finish out the chapter. Next week, we don't have class on Monday because it's Labor Day. So when we do have class on Wednesday, it's going to be kind of a review day because the exam is going to be up next Friday, a little over a week and a half away. You have until Sunday the 13th to finish it, but I will post it on Friday for those of you who maybe work on a weekend so you can do it before the weekend starts. More information on the test to come. But with all of those announcements, let's get started. So with conversions, we learned 2 types, English to metric and then metric to metric. So how the conversions are usually going to look is either going to be a word problem where it says a football player ran 270 yards. How many miles did he run? Okay, so it might be in a word problem form like that, or it might simply just be 270 yards is equal to blank miles. Okay, so both would be asking the same type of question, the exact same conversion. So the first thing you want to do when approaching a conversion is figure out what type it is. So to figure out the type, basically if it has a letter in common, it's metric to metric. Okay, and I'll look at a metric to metric one next so you can see what that looks like. But for these, the units, notice there's no letters in common. Okay, we have a Y and a D, an M and an I. So that tells me itself that it's not going to be metric to metric. So if it's not metric to metric, I'm looking at this conversion factor sheet, and I'm going to try to find a conversion factor that goes from yards to miles. I have one. So looking at it, if you can't find one that goes from yards to miles, then find one that goes from yards to something else. Okay, so it might need more than one conversion factor to get there. I think this one's going to actually be a really hard one now that I'm looking at it, but that's okay. So let's see. I have 2 choices that have yards in it. So I'm looking under length in the conversion factor area. I can pick either one because both of them are yards to meters. So I'll just pick the first one I see, which is 1.09 yards equal to 1 meter. Okay, so this is my first conversion factor that I find, and it's not getting me to miles, but it is going to get me to meters. What I'm drawing here is kind of my steps. I can keep track of them better. So for that first step, I'm going to use this conversion factor here. All right, so from there, I'm in meters. want to go from meters to miles somehow. Okay, now if I look at this conversion factor sheet, I don't have meters to miles. What I do have is kilometers to miles. See that last conversion factor is kilometers to miles? So meters, kilometers, it's in the same range. They're both metric. So I'm going to write that conversion factor down. 609 kilometers equals 1 mile. Okay, so if I can get this here, kilometers, then I can use this conversion factor to get to miles. This is going to be, this step here will be from kilometers to miles. So I know what I'm doing for these two steps. What am I doing for this middle step? Well, we said when we're approaching conversion problems, you want to look and see what type, okay? If there's a letter in common, I said it was going to be metric to metric. Well, notice this part here, from meters to kilometers, they do have a letter in common. So meters, kilometers. So this part is going to be a metric to metric. Okay, so we're doing it all in this one. So let's start and do this first step. We're going to start with our railroad tracks, and we're going from yards to meters. So what we're going to want to start with is the yards, and what we have is 270 yards. So your original number in the original question is always what you're going to put in this upper left-hand corner. We're going to start with 270 yards. To get to meters, our first step, we're going to use this first conversion factor we found. I'm going to take this conversion factor and put it here. So we can write this conversion factor in two different ways, with the yards on top or with the meters on top. I read it in fraction form because imagine picking these up and putting them right here where this space is. Okay, so the one we want to pick is going to be the one that's going to cancel out our yards because we don't want yards. So we want the second version because that'll put yards on the bottom and the meters on the top. And the reason we want yards on the bottom is because this horizontal line's a division line. So if I have the same units on opposite sides of that line, they're just going to cancel each other out. And that's what I want. When I do this, I will have it in meters. So if I take 270, just multiply across, so multiply by 1, and then divide that by 1.09, I get 247.7. Now I'm in meters, but I don't want to be in meters, so I'm going to keep going. So that's just that first step. So I'm here at meters. Now I'm going from meters to kilometers. Okay, and we said letter in common, that's metric to metric. So for metric to metric, we're not using a conversion factor. What we're doing is we're just moving the decimal point. Removing the decimal point by using the prefixes, this scale that we talked about in the PowerPoint and on Monday. So what this scale is are the prefixes of the metric system. Okay, so this is the metric to metric. Kilo, hecto, deca, deci, centi, and milli. All right, so these are our prefixes, and if you need to know those prefixes, they're also on your conversion factor sheet at the bottom where it says metric to metric. I have the prefixes written there as well. So when we use this scale, notice there's an empty space, and what we're going to put in that empty space is the unit that we're measuring. So what I mean by that is, in this case, we're measuring the length. So since we're measuring length, we're looking at meters. So it's the letter we have in common. We have an M in common. That's what's going to go in this empty space for meters. For metric to metric, I said all we're doing is moving the decimal. What this scale is going to help us do is figure out how many times to move the decimal and in what direction. Okay, so I'm going to start at the M. That's what I have my original number in, is meters. And I'm going to go to the K, kilometers. So how many times do I have to move the decimal to go from the M to the K? So I have to move it once to get it to deca, twice to hecto, and 3 times to get it to the kilo. So I know I'm going to start at this decimal point and I'm moving it 3 times. But what direction? The same direction I did on this scale. So I moved to the left, started the decimal, and moved 3 times to the left. So 1, 2, 3. That's going to give me 0.2477 kilometers. By moving that decimal, I am now at kilometers. I've done my metric to metric step. All right. My last step now is to go from kilometers to miles. I start with the kilometer version. I'm going to use the second conversion factor I found, go between kilometers and miles. So since this doesn't have the meters, right? They're not both metric. We're using a conversion factor, so we're doing the railroad tracks. Just like we did over here. I'm going to take the conversion factor and I'm going to put it here, and I'm going to put it so that I'm canceling out what I don't want and keeping what I do. So what I do want to keep is the miles. What I'm trying to get rid of is the kilometers. So I'm going to put miles on the top because that's what I want to keep, and the kilometers on the bottom. That way, kilometers, opposite sides of the horizontal line, they're going to cancel. And then to solve for this one, horizontal line is a division line, so we're taking 0.2477 times 1 and dividing it by 1.609. Okay. I get a wrong number. So this is going to be our final answer. We want to make sure we're paying attention to significant figures. There's a lot more numbers than that, but I'm going to stop there and figure out how many sig figs my answer should be in. So we're going all the way to the original number. When you're figuring out significant figures in conversion columns, you're just using the original number in the original question itself. We're not using any numbers from the conversion factors. So in this original number, let's count the sig figs. I know the 2 and the 7 count because they're not zeros, but does this 0 count? It doesn't. Why? No decimal. Exactly. So this one does not count, so we just have 2. So I want 2 in my answer. So let's go over here. I start at the 1, your first non-zero number. 5 will be my second significant figure. Always look to the number next to it. And in this case, it stays a 5. Get 0.15 miles. Now, that one was a lot of steps. This is the hardest type of conversion problem you'll see. Most of the ones that you see on the homework and the exams are going to just be one of these steps, not all 3 combined. Okay. You might see one this hard on the homework. But only if you'd only see one of them. Not all the problems are this difficult. Most of them are just, like I said, one step. All right. Try another one. Good eraser and a bad eraser. So let me. So that was like 3 problems in one. Let's just do 1 problem in one this time. So I want to do the other one I had written? 0.083 kiloliters. We're going to go to centiliters. Here's another conversion problem. Okay, first step, what type is it? That way I know where to look. Am I going to be using my prefixes, the kiss for dummy blank, don't chase me? Or am I going to look at my conversion table and find a conversion factor? So to figure that out, does it have a letter in common? It does. Kiloliters, centiliters. Okay, so the letter in common tells me that this is going to be metric to metric. So if you have metric to metric, that means you can use that KHD DCM, but only with metric to metric. We talked about a few mnemonic devices to help remember that. The most common is King Henry died, space, drinking chocolate milk. If you don't like that one, you can just search mnemonic devices for metric system. It'll come up with a whole bunch of options. So, in that empty space, what letter do you think we're going to put? It's going to be the letter that they have in common. What are we measuring? We're measuring volume, so it's going to be L. All right, so we're just moving the decimal point. That's the nice thing about metric to metric. No division, no multiplication, you just move that decimal point. So we are starting at the kilometers, the K, or the kiloliters, sorry, not kilometers, kiloliters. Starting at the K, and we want to get all the way to the C, to this guy here. All right, so how many times do we have to move the decimal to get from the K to the C? You want to stop at every one of these letters and count it as one place. So 1, 2, 3, 4, 5. So I'm going to move the decimal point 5 times. What direction? Same direction I just did there. I moved it to the right, so I'm going to move 5 times to the right. Okay, so starting at the decimal, 1, 2, 3, 4, 5. What's going to go in those empty spaces? Zeros. Okay, so 0.083 kiloliters is going to equal 8,300 centiliters. What I'm going to do before I'm done is 2 things. Make sure your sig figs are correct. Make sure you put your units on. So, counting sig figs in the original number, that's how we figure it out. In this one, does this first 0 count as a significant figure? There's a decimal point, and a lot of people will say, oh, decimal point, zeros count. Okay, but no. We can't count the 0 unless we already hit our first non-zero digit. And we don't hit our first non-zero digit till after that 0. So the 8 and the 3 are the only 2 significant figures that count. That means we have 2, we just want 2 here. And these zeros don't count because there's no decimal point, so we kept with our sig figs and we labeled the units, centiliters. So good on both accounts. All right, questions? All right, I'm going to move on then to percent error. So, percent error is something we're going to see. I mean, you'll see an example or a problem on the homework, at least one, and you'll see at least one problem on the exams. But for the most part, we're going to use percent error in lab quite a bit. So this is going to be useful when connecting the 2 courses. So, talking about it, let's put up the equation. And the equations, I'm going to have an equation sheet for all the exams you take. So these equations will be on there. All right, the only thing that might not be on there is that metric scale I just showed you, the King Henry died drinking chocolate milk. That you might need to remember or write down before you sit and get ready to take the exam. Measured minus true over true times 1. Write a problem in which this would apply. It'll help me explain the equation a little bit better. So let's say get the lab, and the student measures the density of water to be 0.915 grams per mil. But actual density of water is 1. We're going to calculate that curve. So how we're using percent error is the reason we use it a lot in lab is because you're going to be taking measurements, you're going to be doing calculations, and you're going to be comparing those measurements that you take to the actual, true, theoretical, proven values. So what you want is a very small percent error, because that means you got close to what you should have gotten. Right? If you have a very large percent error, something went horribly wrong, or you simply calculated the percent error incorrectly. So we don't want the latter to happen. We want neither to happen, but especially the latter. So we're going to practice using this equation so it doesn't. So when you're using it, the measured is obviously what the student did, the experimental, if you will, what was done during the lab period. Okay, the true, that is going to be the theoretical value, the value you get from the table, the proven value. So we're going to read the word problem and figure out, because you will be given 2 different values, which value is measured, which value is the true, and then we'll plug them into the equation. So reading it, we have the first number, that 0.915, the student measured the density. That 0.15, that's going to be the experimental, the measured, the one the student did. Okay, so just circle this and say that's our measured or experimental. See those words used. So that by default, we know the other number is going to be the true. But the wording helps figure that out as well. It says the actual density of water, the true density of water, the theoretical density of water. Okay, so true, actual, theoretical, all these words will be used in word problems to give you a hint of what that number actually means. So now that we know which is which, we plug them in. So let's see how close the student was to the actual value, to the true value. So notice this equation has bars around the subtraction that we're doing with the measured and true value. Those bars are called absolute value bars. All that means is if you happen to get a negative number when you subtract those two, change it to a positive. You're not changing the magnitude, you are just simply changing the negative sign to a positive. So the measured, in this case, we said was that 0.915. The true was the 1.00. And then we're going to divide by the true. Oh, don't forget to multiply by 100. An important part. So make sure you're doing what's in the parentheses first. When I subtract those two, I'm going to get a negative number. I'm getting negative 0.085. But remember, with those absolute value signs, we just want to take off the negative. Okay, so what I get when I do just the subtraction, I have 0.085 in my numerator, and then I still have that 1 in my denominator. I'm just kind of showing it step by step here. This is just what I had up here. Okay, so anything divided by 1 is just itself again. So then you multiply by 100, and I get 8.5%. So the units on it that we're using is percent. Why? Well, because the units on these up here were grams per mil. The units here were grams per mil. And if we have the same units on opposite sides of a horizontal line, those units cancel. we don't have any units on this, it's just a percent. So what this is saying is they were 8.5% off of the true value. It's really just plugging in. The hardest part is figuring out which number is the measured and which one is the true, and then making sure that you're doing the subtraction part before the division. And you can simply do that by putting parentheses around that part when you enter it into your calculator. So not too much. So I showed another example on the PowerPoint. If you want more practice, you can try that one as well. All right. So this one's pretty straightforward, so we're actually going to move on to density. Density is the last topic of chapter 1. Meaning, after we cover density, you can even do a part 2 chapter homework. All right. So with density, let's start by just looking at the equation itself. Okay, so density equal to mass over volume. Often I just say D is equal to M over V. Let's explore this further. So for the mass portion, that is usually measured in grams. In this course, that's what we'll see it measured in is grams. Represented by the letter G, metric, right? We're doing metric in the class. For the volume portion, that is usually measured in milliliters. ml. So once again, metric, right? Liters, milli, metric. So these are also going to be word problems. Sometimes you will be calculating for density in which you just need to plug the mass and volume into this equation and solve. But that's not always going to be that simple. Sometimes you might need to solve for the mass portion or the volume portion. And then you'll have to rearrange the equation to solve for what the question is asking for. Right, and I'll show you how to do that once we do some of the word problems here. Before that, I want to mention the units on density. So since density is mass, grams, divided by volume, milliliters, the units are going to be grams per milliliter. Now you might also see grams per centimeter cubed. The reason for this is because milliliter and centimeter cubed are the same thing. Okay? We use milliliter when we're talking about a liquid. Because for a liquid, we'd get out a graduated cylinder and we would measure the liquid in milliliters. For solids, you'll see centimeters cubed because a solid, so if you think of a solid aluminum block, measure the volume of that, we would get out a ruler and measure its dimensions. So it would be in centimeters that we would see solids. But they mean the same thing. They're interchangeable in this course. Okay? So let's look at how we're going to apply this equation. Let's write a word problem over here. Calculate kind of introduction to word problems. We're going to be doing a lot of them in the next chapters. The question, first one, is asking us to calculate the density of 5 grams of solution that has a volume of 7.3 milliliters. So the goal is to figure out what those numbers are. Sometimes it straight up tells you in the question itself. For instance, down here it says it has a volume of. So it's specifically telling you that 7.3 milliliters is a volume. Okay? I'm just going to write V for volume is equal to 7.3 ml. If it didn't explicitly tell you that, you can figure that out based off of the units. Because we said that volume is measured in either milliliters or centimeters. So that other number is in grams. So is that going to be the mass or the density? So grams we said was mass, right? So that's going to be our M. The density is what it's asking us to calculate. And the reason I'm making this list is I know these are problems with very few variables, but next chapter, this is how we're going to approach problems. We're going to start with the list because we're going to have 5 or more variables sometimes. So it's nice to just start a list of them to keep track of them, and it's really going to make the problem solving easier. So it's good to get in the habit now. So now I can find the appropriate equation and just plug in. Put my mass, my 5 grams on top. And put my volume, that's 7.3 on the bottom. 5 grams and milliliters. And put my units with it just so you can see a little better what that is. We have 5 divided by 7.3. A big long number, but I'm going to count my sig figs, so I'm not going to use all these in my final answer. I'm going to go back into my word problem or to my variable list over here, and I'm going to count the sig figs in the numbers I'm using. So for volume, I have 2. For the mass, since there's a decimal, that 0 does count, so I have 2 as well. You always pick the smallest, but since they're both 2, choose how many sig figs we want in our answer. So we go over here and count out 2, 6 and the 8. You look to the number next to it, and it's going to stay an 8. So I get 0.68. And for my units, if I didn't memorize over here that it should be grams per mil, I can just look at the units of the things I divided. I have mass in grams, volume in mil, so my units will be grams per mil. One more. I think we have time for one more. Oh, yeah. So this was the most straightforward type of density problem you're going to see, where it's asking you to solve for density, and you simply plug it into your prearranged equation. Well, now we're going to look at one where we're solving for mass or volume and see how to rearrange the equation. And I have a kind of a trick to do that makes it a little easier. So let's look at what volume will 10.2 grams of benzene occupy given density. Okay. So, read the word problem, figure out what the numbers represent, what their variables are, and then what they're asking for. So this first number, 10.2 grams. So grams would be M, the mass. Okay? I know that because of the grams. Now, the next piece of information is 0.879 grams per mil. So you can figure this out by the clue, density, right? It says D, density, or the fact that the units are grams per mil, because those are the units on density. And then I forgot to put a point there. It's not 879, that would be an extremely dense liquid. 0.879, okay? So what we're solving for this time is volume. It says what volume? So question mark by V. So the equation that we have is D is equal to M over V. Well, I'm going to have to rearrange that so that I have V by itself to solve for V. This triangle is going to help me do that, all right? So when I'm drawing this triangle, I just take these variables and plug them in. D, M, V. Like going to get your license, right? D, M, V. The M at the very top of the triangle. So how do we use this triangle? Well, it's just like when we were doing conversions. The horizontal line means division. Any vertical lines are going to mean multiplication. So to use it, what you're going to do is whatever it's asking you to solve for, you're going to cover that variable up with your hand. So it's asking us to solve for volume, so I'm going to cover up the V. And then what you're going to do is the order of operations on the other two. So if I cover up the V, it tells me that I should be taking the mass and dividing it by the density. I'm going to write that equation down. Solve for volume, covering that up, mass divided by density. Mass over density. So there's my rearranged equation. Let's bring it over here and plug in what we have. I'm going to put my mass on top, 10.2 grams. I'm going to put my density on the bottom, 0.879 grams per mil. I'm including the units just so you can see what's happening to them, okay? Remember, if we have units on opposite sides of this horizontal line, they cancel. So I have grams and grams, so those units cancel. And my answer is going to be in milliliters now. So let's divide the numbers now that we know what's happening to the units and see what's happening to the numbers. So 0.879. I get 11.604, etc. 11.604. And there's more numbers after that, but I'm stopping because I'm going to count my sig figs and see what I need. So I'm going to the sig figs of the numbers that I divided. So I have 1, 2, does that 0 count? Yeah, so it counts because it was decimal or because it's between two non-zero digits, both apply. So I have 3 sig figs here. Down here, I don't start counting till the 8, so I have 3 as well. So smallest of the two, they're both 3, so I want 3. 1, 2, 3. Look at the number next to it. It is a 0, so is that going to stay a 6 or go up to a 7? Stay a 6. And then don't forget your units. Now, if you include your units when in your calculations, that might help you figure out what your unit should be. If you prefer to just memorize, that's fine too. So volume should be measured in milliliters. So it's ml for the units. So 10.2 grams of benzene will be 11.6 milliliters in volume. So on Friday, I'll probably just post a very short video just doing a couple more density problems because we haven't done one solving for mass yet. And I want to show a few others, no conversions involved. So that'll be it for today. But we'll sum up the chapter on Friday, and then next week will be for review. So you'll have time to work through your assignments and start studying for the exam.